strong bases. Strong bases are completely ionized or dissociated in solution. BOH aqueous gives B plus aqueous plus OH minus aqueous. BOH is metal hydroxide. B plus is metal plus ion. OH minus is hydroxide ion. Example, sodium hydroxide aqueous dissolve completely to give sodium plus ion plus OH minus aqueous ion. The concentration of hydroxide ions, OH minus, is equal to the concentration of the base because of complete dissociation. All the BOH turned into B plus plus OH minus. BOH concentration equals OH minus concentration. We can use POH equals minus log base 10 OH minus concentration, which is a logarithm function, or we can use concentration OH minus equals to 10 to power minus POH, the exponential function. What we did was we can turn the logarithm function into exponential function by multiplying both sides by minus 1. This side will be minus, and that will be plus, and then we raise the 10 to the power of minus POH, and the answer will be equal to concentration of OH minus. We use logarithm function to solve exponential function, and we use exponential function to solve logarithm function. They are interchangeable. We can also use POH plus pH equals 14, or concentration of H plus times concentration of OH minus equals Kw, the ionic product of water, and that equals 10 to the power minus 14. We know pH equals minus log base 10 concentration of H plus. We know the concentration of H plus times the concentration of OH minus equals Kw, which equals 10 to the power minus 14. We also know that this is ionic product of water. If we make concentration of H plus the subject, we have to divide both sides by the concentration of OH minus, and we get concentration of H plus equals to Kw divided by the concentration of OH minus, and that will make concentration of H plus equals 10 to the power minus 14 over concentration of OH minus. And we can replace the concentration of H plus here with the concentration of H plus here, and that will be equal to pH equals to minus log base 10 the concentration of H plus, which is 10 to the power minus 14 over concentration of OH minus. So here I have just replaced the concentration of H plus, which is this, into there, and this is what I get. Question 1. Calculate the pH of 0.3 mole per decimeter cube of sodium hydroxide NaOH. Sodium hydroxide will dissociate completely, giving sodium plus ion plus OH minus ion. The concentration of sodium hydroxide will be equal to the concentration of OH minus ion, because all the sodium hydroxide has turned into sodium plus and OH minus, giving the concentration of sodium hydroxide, and that equals to concentration of OH minus because it's a strong base. POH equals minus log base 10 of concentration of OH minus. POH equals minus log base 10 0.3, and that gives 0.25. From the calculator, pH plus POH equals 14. pH equals 14 minus POH. pH equals 14 minus 0.52, pH equals 13.48. Question 2. Calculate the hydroxide concentration of a solution of sodium hydroxide when the pH is 11. Hydroxide is a strong base, so it will dissociate completely, forming sodium plus OH minus. The concentration of the base sodium hydroxide will be equal to the concentration of OH minus because all the sodium hydroxide has been converted to sodium plus and OH minus, and the ratio is 1:1. So their concentration will be the same. We are given pH equals 11, therefore pH plus pOH equals 14. pOH equals 14 minus 11, pOH equals 3. To find the concentration of OH minus equals 10 to the power minus pOH. And if we replace the 3 here, we get OH minus concentration equals 1 times 10 to the power minus 3. And therefore equals 0.001 mole per decimeter cube.